Yo, what's up, everyone? Good morning. Good morning. Hope you're doing well. And we're here again. Nearing the end of the year, it's nuts. Kids are going to go back. I'm not going to go back. We're doing the same stuff. And if you're still here, a lot of people still here. I really do appreciate you. And honestly, and this is not even prepared, but honestly, I feel like for the rest of your life, if you were watching this algebra 2, like you're in a good place with math because that's the cool thing about algebra 2. We learned all pretty much every different symbol that you could see, all the basic types of functions. And now we're at logs, which is pretty common in the real world. Um, so yeah, really always want to honor all the work that you guys have done watching these videos. Less people watch it in algebra 2 than in statistics, so you might feel like there aren't that many people, but it's more than you think who have learned quite a bit. Um, anyway, we're working on logs now for the next 3 weeks. And what I really actually wanted to say about this worksheet, and maybe this week and maybe last week, is that I understand that this stuff maybe sucks. It's not my favorite stuff to teach. It's pretty tedious. And it's so random. It's like I've never even seen this word log before. What is a log? But all we're doing is trying to develop our math skills. So this unit will feel better once we start graphing again. I think the graphs tie everything together. So just think right now we're trying to really just understand logs before we graph. Okay. So this is our third log lesson because we did one before spring break. And what we're going for is a new logarithm rule. But let's just start this one with review. So 1 and 2 are very similar to what we did, or the same that we did on day 1. I felt like my camera was kind of sideways. Sorry, guys. Okay. So number 1, just to simplify the following logarithmic expressions and solve. And we see log base 3 of 9 plus log base 3 of 81. And I want to do this really quickly. But basically, like what we did before was a single log. And what a single log means is this is the base number, and it's this number raised to what power gives me the top number. So what we say is log base 3 of 9. And what that means is what number do we have to raise 3 to get to 9? So the answer to this log would be 2, okay? Just thinking, if you feel really weird about it, think like we've seen exponents before. Everyone knows an exponent. 3 cubed is 27, right? 3 to the third power equals 27. So just think of this as like not an exponent, but some kind of math that you do. Log base 3 of 9 equals 2, okay? And then this one would be 4. But what we're really interested for this one is how can we combine these logs? Anytime it says simplify, we want to take what we see and kind of make it easier. And the rule that we learned is that as long as they have the same base number, we can multiply the top numbers together to turn it into a single log, okay? So again, let's just focus on kind of crushing the actual math today. That's what you have to do to simplify it. And it's simpler because it's 1 log instead of 2 logs, right? So 9 times 81 is 729. Log base 3 of 729. And yeah, I always am like, you should Google power table if you're kind of looking to do a lot of these in your head. Because the power table tells you any number raised to what power, what it is equal to. So here, this is a good example. If we want to figure out 3 to what power gives me 729, it's 3 to the 6. And just Google power table, okay? So this is how you simplify it. And then we also know what it equals. It equals 6, right? So you can check your work and think that 3 to the 6th power is 729. So we call that the addition rule of logs. And the subtraction rule is obvious, or not obvious, but we can figure it out because it's going to be the opposite. Addition, you multiply. Subtraction, you divide. So they have the same base number, and we take the first log divided by the second log. So log base 4. And then when you get fraction logs, it can look kind of tedious or confusing. Just keep these two numbers separate, right? Log base 4 of this number, we can tell it's going to be a fraction. It's going to be 1/4. And don't forget that while most of the time I'm going to test you with positive logs, because that's like the most common, we can definitely solve a fraction log, right? So 4 to what power gives me 1/4. If you want to turn a number into a fraction, that means it's a negative exponent. So it's going to be -1, right? So 4 to the -1 is equal to 1/4. So just always kind of keep that in mind. So that was the last rule. That was what we did yesterday. And now let's read what it says. It says simplify the following expression into a single log by turning the coefficient into an exponent. So we want to simplify this, okay? What we see is 3 log base 8 of 512. And first, if you see a number on the outside of any expression, that just means 3 is being multiplied to this, okay? So this rule is actually really intuitive. I think it's kind of cool. What this means is log base 8 of 512 3 times, right? We know that something like 3 times 5 means 5 times 5 times 5. So 3 times log base 8 of 512. And this is our logic. So we're kind of just down into logic. Think that it's 3 of these log base 8 plus 512. Crap, I said that wrong. Log base 8 of 512, right? Three times this means 3 of them. And what did we learn from our first rule? If we have the same base, we can multiply the top numbers together. So just because we have 3 doesn't mean that we can't do the exact same thing. And it would be 512 times 512 times 512. Hopefully that makes sense. Now, this is the part that's the best, the coolest part. What is 512 times 512 times 512? It's a huge number, but this is 512 cubed, right? So if we have an outside number, an outside coefficient, that means we're multiplying that log to, or adding that log to itself a bunch of times, which really means we're multiplying that top number to itself this many times. Hopefully you can see this. If it was 5 log base 8 of 512, it would be 5 512s, which just means log base 8 of 512 cubed, right? Pretty cool. We should still solve it. I mean, we could have solved it from here, but that is the general rule. A coefficient, which is the outside number, all you do is you put it as the exponent on the inside. Very, very easy. We're gonna get a really high number here, 512 cubed. So what we just simplified that to was log base 8 of 134217720, which, believe it or not, is on the chart. I think. Maybe not. What was it? No, it's even past the chart, and that's okay. So that is what this is. I'm gonna guess it's 8 to the 12. No, 8 to the 11. So there's kind of some experiments necessary sometimes. It is on the chart. I think I'm just being silly. I wrote the what did I do? I can't even figure it out. Oh, I wrote the last number wrong. Okay, yeah. Good. I won't even edit it out, but I did just waste your time a bit. But this log is 9 as the answer. And it's on the power chart. Okay. Hopefully that makes sense. So that is like the whole lesson, the whole big new idea. A coefficient in front of a log can become the exponent. That's going to become more useful now that these questions could get harder. We have 6 log base 2 of 4 squared. And, there's a few approaches. 4 squared, we actually know is just 16. But even if we don't do that, we can just start this question by taking that 6 and bringing it above this number. So remember that an exponent of an exponent, we like to start by putting in parentheses. So this is log 2 4 squared to the 6th, right? And then we're now using the exponents rules where an exponent of an exponent is multiplied together. So this is going to become log base 2 of 4 to the 12th. And now we can solve that before we go for the final answer. And I think this is also going to be a massive number. But it's log base 2 of 16 million. I think I just did that second example kind of quickly, but I hope that you guys kind of can see the logic, right? We don't want this outside number, so we bring it to the top, which becomes the exponent of the top number, right? So this log is going to be the 24th, okay? Because if it's 4 squared, think that, 4 to the 12th, 2 to the 24. Can check our work though. Good. So we do have more, and I'm going to make it to the end of the worksheet. A lot of the videos have been short, but let's just make sure we're really solid. 5 and 6 are less useful. Let me even write that. But sometimes you want to go the other direction, okay? So here it says, and when you're doing the practice problems, it's going to be the same as you always where you follow my format. But this says to rewrite the following logs with exponents into logs with coefficients. So here we see log base 5 of 25 to the 10. And you can do 25 to the 10th power, and you'll find that this number is just obnoxiously big. But then you might realize that if you move this 10 over here, log base 5 of 25 is actually really easy. So if you need to, or you can, or it's more useful, you can go backwards. And going backwards is really useful if the number becomes way too big. And what we can do from here, hopefully, is it's 10 times this, and log base 5 of 25 is 2, because 5 to the second power equals 25. So it's going to be 10 times 2, which equals 20. So even though this is like more common to ask to simplify it by bringing this way, if you're ever asked to kind of solve any log, going the opposite direction might help you get that final answer. This is a similar situation where if we take away this 5, this becomes even easier to solve, right? So if you want to bring this number to the outside, you're going to multiply it to what's already there, right? So we're bringing the exponent, so it becomes 5 times 4 log base 2 of 2, and 5 times 4 is 20. And we like this because any log with a small number is easier, right? And if they're the same, it's always 1, right? Because we know that 2 to the first power is 2, right? If it was log base 2 of 4, it's 2 squared, but 2 to the first power is 2. So this was accidental, but we're gonna get 20 again as the answer. So, sorry, excuse me. So for these last two, and I did typo, I'll probably forget to change it on yours too. We're gonna combine some rules. Okay, so here we have 2 logs to add together, but we can't add this one yet because there's a 3 in front of it, right? So our log rule, it doesn't say anything about what do we do if there's a number here, right? It might be confusing. Do we put it here? What do we do with it? And what we're going to do is we're just going to turn this into something that we can solve, which means let's just take that coefficient and bring it on top of the 8. Once we do that, we have log base 2 of 8 cubed. And that's still not something that we can just start solving or start simplifying. But if we do 8 cubed, then it's going to look just like yesterday's worksheet. So again, fundamentally, turn anything you don't know into something you do know. Once we have it like this, let's just multiply the top numbers together. But hopefully at this point, you know the drill. So this is the same thing as this, okay? So you should be proud of yourself. You've accomplished quite a bit, right? We're taking these really complicated expressions and turning them into single logs. And here, I'm gonna guess that it's 14. And that's my strategy a lot if I have to figure out these answers. And that's half the answer. So it's for sure 2 to the 15. Let's do one more. Here, let's move the 4 to the top. And here, let's just solve this. 9 squared is 81. Let's simplify this, but because we see subtraction, and I can tell I'm gonna run out of space. Let me just do this whole thing on a new page. My bad. Okay. Log 3, 243 to the 4 minus log 3, 81. Let's simplify this one. So we have 243 to the 4th, insanely big number, but it's going to get slightly smaller now because the rule we can't forget is if we see subtraction, we take the first one dividing by the second one, and that becomes the top number. So I hate that I have to write it one more time, but whatever. Okay. So I'm just going to take the number that was already in my calculator. That's hilarious. I messed up. 243 to the 4th divided by 81. Crazy big numbers still. But let's try to guess what this is going to be. I think it's going to be maybe something as big as 12 again. Way too small, so let's try it to the 20. And it's somewhere in between. Okay. 3 to the 14. Oh, wait, that was the right answer. Yeah, 3 to the 16. Okay, cool. So that's that. That is our final log rule. So hopefully you thought that was good. And remember, we're building towards graphing, and I'm really proud of you. So no quiz this week or anything. I'm going to work on some more solving next week.